Hey everyone, welcome back to TechXplorePRO. Today we're tackling a big one: Power BI data modeling. Data modeling is the secret sauce to unlocking the true power of Power BI. We're talking crazy fast reports and insights that actually make sense. Whether you're a seasoned Power BI pro or just starting out, this video is jam-packed with tips and best practices to take your data modeling game from May to whoa, that's impressive. So, grab your favorite energy drink, get comfy, and let's dive into the world of Power BI data modeling. And hey, while you're at it, smash that like button and subscribe to the channel if you haven't already. Alright, let's talk data modeling. It might not sound as glamorous as building those fancy dashboards, but trust me, it's the foundation of everything in Power BI. Think of it like building a house. You wouldn't just start slapping on walls and windows without a solid foundation, right? Data modeling is all about organizing your data in a way that makes sense for analysis. It's about creating relationships between different tables, cleaning up messy data, and making sure everything is in tip-top shape. When you get data modeling right, the rest of your Power BI journey becomes a whole lot smoother. Your reports will be lightning fast because Power BI knows exactly where to find the data it needs. You'll avoid those annoying data errors that make you question your sanity. And best of all, you'll be able to build complex dashboards and analyses without your computer sounding like it's about to take off. So yeah, data modeling is important, folks. It's the unsung hero of Power BI, the behind-the-scenes magic that makes everything else work flawlessly. In the upcoming chapters, we're going to break down the key principles and best practices of data modeling in Power BI. Alright, so you're ready to dive into the world of data modeling. That's awesome. But before you even open Power BI, we need to have a little chat about your data. You gotta understand your data inside and out. Think of it like going on a road trip. You wouldn't just hop in the car and start driving without knowing where you're going, right? You need to know what data you have, where it's coming from, and what it all means. What are the different tables? What are the columns in each table? What do those columns actually represent? Once you have a good handle on the what of your data, you can start thinking about the how. How are these tables related to each other? What are the key columns that connect them? This is where things start to get interesting because you're basically building a roadmap for Power BI to follow. Understanding your data up front will save you a ton of headaches down the road. It'll help you design a data model that makes sense, avoid errors, and build reports that actually provide insights. So spend some quality time with your data, get to know it, and I promise it'll pay off big time. Okay, let's talk data modeling design, and more specifically, the star schema. Don't worry, it's not as complicated as it sounds. Imagine you're looking at a beautiful symmetrical star in the night sky. That's kind of what a star schema looks like, at least in the data world. At the center of our data star, we have our fact table. This is where we store all the juicy, measurable data. Think sales figures, website traffic, or maybe even the number of cups of coffee you've consumed while working on your Power BI reports. Now, surrounding our fact table, we have our dimension tables. These tables provide context to our fact table. They contain descriptive information about things like products, customers, time periods, or even types of coffee beans. The beauty of the star schema is its simplicity. It's easy to understand, easy to implement, and it makes your Power BI reports run like a dream. Why? Because it reduces data redundancy and simplifies relationships, which means faster queries and happier users. So when you're building your data model, channel your inner astronomer and aim for that elegant star schema. Your Power BI reports will thank you for it. Okay, so we've talked about the star schema, which is awesome for organizing your data, but sometimes you need to go a step further, and that's where normalization comes in. In a nutshell, normalization is all about breaking down those massive, unwieldy tables into smaller, more manageable ones. Think of it like organizing your workshop. You wouldn't just throw all your tools, parts, and projects into one giant bin, right? It would be a nightmare to find anything. Normalization is like adding shelves, drawers, and labels to your workshop. It's about creating a system where everything has its place. In the data world, we do this by identifying related data and splitting it into separate tables. For example, instead of having one massive customer table with all their information, you might create separate tables for customer details, addresses, and order history. Now I know what you're thinking. Isn't this just creating more work? And yeah, it might seem that way at first, but trust me, normalization has some serious benefits. It reduces data redundancy, which means less storage space and faster queries. It also improves data integrity by ensuring consistency across your data model. So, if you're dealing with large, complex datasets, don't be afraid to embrace normalization. It might take a bit more effort up front, but the long-term benefits for your Power BI reports are well worth it. Now let's talk about relationships in Power BI data modeling. No, not the kind you have with your computer, though those can be complicated too. I'm talking about the relationships between your data tables. Remember how we talked about creating those separate tables in the normalization chapter? Well, now it's time to connect the dots and tell Power BI how those tables are related. Think of it like building a family tree. You've got your different branches representing your tables, and now you need to draw the lines that show how everyone is connected. In Power BI, we do this using primary and foreign keys. A primary key is a unique identifier for each row in a table, like a social security number for people or a product ID for products. A foreign key, on the other hand, is a column in one table that refers to the primary key in another table. It's like saying, hey, this person is related to that address, or this order belongs to that customer. Power BI uses these relationships to understand how to combine data from different tables, and it's what makes those awesome visualizations and insights possible. So when you're building relationships, make sure they're accurate and well-defined. It's like giving Power BI a clear set of instructions on how to navigate your data model and deliver those mind-blowing reports you're known for. Alright, let's talk about calculations in Power BI, specifically the epic showdown between calculated columns and measures. Now, both of these bad boys let you perform calculations on your data, but they do it in slightly different ways, and knowing when to use each can make a huge difference in your report performance. Think of it like this. Calculated columns are like pre-cooking your meals for the week. You're doing the calculations up front and storing the results directly in the data model. This is great for calculations that are static, meaning they won't change based on how you filter or interact with your report. Measures, on the other hand, are like ordering takeout. You're telling Power BI what calculations to perform only when you need them, based on the specific filters and slicers you're using in your report. This is super handy for dynamic calculations that need to update on the fly. So, when should you use each one? Use calculated columns for calculations that are done once and don't change, like calculating the age of a customer based on their birth date. Use measures for calculations that depend on filters or slicers, like calculating total sales for a specific product category or time period. By choosing the right tool for the job, you can optimize your Power BI reports for speed and efficiency. And nobody wants a slow report, right? Okay, let's talk about data types in Power BI. Now, I know this might sound a bit dry, but trust me, it's more important than you might think. Choosing the right data type for your columns can significantly impact the performance and efficiency of your Power BI reports. Think of it like this. You wouldn't try to fit a square peg into a round hole, right? The same goes for data types. Each data type is designed to store a specific kind of data, and using the wrong one can lead to errors, wasted space, and slower reports. For example, if you have a column that stores numerical data like sales figures, you wouldn't want to use a text data type. Why? Because Power BI would treat those numbers as text strings, making it impossible to perform calculations or aggregations. Power BI offers a variety of data types, including text, whole number, decimal number, date, time, and even geographical data. Take the time to understand each data type and what it's best suited for. By using the right data types, you're essentially optimizing your data model for efficiency. Power BI can store and process the data more effectively, resulting in faster queries, smaller file sizes, and a smoother overall user experience. So be kind to your data and choose those data types wisely. Alright, let's talk about data security in Power BI data modeling. Because let's face it, data breaches are no joke, and we want to make sure our sensitive information is locked down tight. Now, Power BI has this awesome feature called row-level security, or RLS for short. Think of it like a digital bouncer for your data. It lets you control who sees what based on their user roles. So, let's say you're working with sales data, and you don't want everyone to see the sales figures for every region. With RLS, you can set it up so that sales reps from the East Coast can only see data for their region, while the West Coast team can only see theirs. It's like having invisible walls within your data that only certain people can pass through. Now, setting up RLS might sound complicated, but it's actually pretty straightforward. Power BI has a user-friendly interface for defining roles and rules. You can even test it out to make sure it's working as expected. Remember, data security is not something to be taken lightly. It's about protecting sensitive information, maintaining user privacy, and ensuring that your Power BI reports are only accessible to the right people. So take the time to implement proper security measures, and you can rest assured that your data is in good hands. Okay, we're almost at the finish line, but before we wrap up this data modeling marathon, we need to talk about documentation. I know, documentation might not sound like the most exciting topic, but trust me, it's crucial, especially when it comes to Power BI data models. Think of it like this. Imagine you've built this amazing, complex machine with all these intricate parts and connections, but then you don't leave any instructions or diagrams on how it all works. What happens when someone else needs to use or modify your machine? Chaos. Documentation is like leaving a trail of breadcrumbs for yourself and others who might work with your data model in the future. It's about explaining your thought process, the relationships you've created, any custom calculations you've added, and any assumptions you've made along the way. Trust me, future, you will thank you for taking the time to document your data model. It'll make troubleshooting a breeze, updates a walk in the park, and handovers much less painful. Plus, it shows that you care about the long-term maintainability of your work. So, don't be that person who creates a data model black box. Document your work, and make the world a better place, one data model at a time. Alright, we've reached the final chapter of our epic Power BI data modeling adventure. And what better way to end it than with a reminder to test and validate your data model. Testing your data model is all about making sure it's accurate, reliable, and performs as expected. It's about catching those pesky errors and inconsistencies before they turn into major headaches down the road. Start by verifying your data sources, ensuring that the data is flowing in correctly, and that any transformations you've applied are working as intended. Next, validate your relationships. Make sure the connections between your tables are accurate and that the data is being joined correctly. Finally, test your calculations. Check your calculated columns and measures to make sure they're producing the expected results and that there are no logical errors. Remember, a well-tested data model is a happy data model. It means you can trust your data, your reports will be accurate, and you'll avoid those embarrassing moments when someone points out a glaring error. And there you have it, folks. We've covered a ton of ground today, from understanding your data to implementing robust security measures. Remember, data modeling is the backbone of any successful Power BI project. By following these best practices, you'll be well on your way to creating efficient, high-performance reports that deliver real insights. Now, I know this was a lot to take in, so don't be afraid to rewatch any sections you need to revisit. And hey, if you found this video helpful, do me a favor and give it a thumbs up. It really helps the channel grow and lets me know what kind of content you guys find valuable. Most importantly, keep practicing and experimenting with Power BI data modeling. The more you use it, the more comfortable you'll become, and soon, you'll be building data models like a pro.